Aldo from Zero to Mastery here. In today's tutorial, we're diving into data types in Rust. Now, this isn't just any tutorial. It's part of Jayson Linen's comprehensive Rust programming bootcamp course, which is available on the Zero to Mastery Academy. If you want to learn Rust completely from scratch or simply just improve your Rust skills, I highly recommend you check that out by clicking the link in the top right hand corner or take a peek at the description below to see the full course. Alright, that's it from me. Let me hand it over to Jayson. Enjoy!
In this video, we'll be taking a look at fundamental data types. I'll be explaining what data types are, and we'll go over a few examples. Now, before we actually dive into a data type, we need to kind of take a step back and look at how computers store data. Now, computers store data in a binary format, and that is a 1 or a 0. And anything can be represented using 1 and 0. So that could be anything. It could be pictures, sounds, words. Now, when we're running a program, we don't have to worry about 1s and 0s. We're not just going to be spamming 1 and 0 the whole time. The computer is actually going to translate that for us. So when we write a program, we'll be representing the program using words that we understand, and then it'll get translated into the 1s and 0s that the computer understands. And there are some data types, and a data type would be like a number or a word. Those can be data types. And some of those are useful across all programs all the time. And the useful ones are provided by Rust itself. And we're going to be taking a look at those next. Now, we aren't limited just to the ones that it's provided. We can put those together to create richer data types, which we'll be doing throughout the course. So here are the basic data types. We have a Boolean, which is either true or false. So the Boolean can be true or false. Booleans are really important because we'll be testing conditions like if something is true, then run this code. And if it's false, then we run some other code. So Booleans are all over the place. Next, we have integers, and those are just going to be whole numbers. They can be positive or negative. There are some limits to the integers, which we'll be covering in the next slide. Next, we have doubles or floats, and these will be floating point numbers. And it's called floating point because we have this decimal here, which is the point, and it can float between really long decimals like this or short ones like 0.0. Next, we have character, and a character is an individual letter. So capital A is a character, lowercase c is a character as well. And if we put the number 6, if we use the single quotes, that's going to get us the visual representation of the number 6. So the actual number 6 itself is different from the visual representation of number 6. That's kind of important, and it could be a little bit confusing at first, but as you write more programs, it'll become a lot clearer. Next, we have string, and a string is just multiple characters put together to create a word. So when we want to have a string, we use double quotes. So hello is a string. We can put the word string as a string. We can have sentences. We can have numbers. Anything you put in the double quotes is going to be represented as you see it on the screen. Now, integers are kind of a special case because they have different sizes available. Because sometimes you only need a few numbers and sometimes you need a whole bunch of numbers. So we have multiple different integer types to facilitate this. Here's a list of all the integer types that are available in the standard library. The I8 and U8, one is signed. So the I means it's signed, and signed means we can have a negative sign. So the range for an I8 is negative 128 all the way to 127. So if you're ever working with data and you only ever need like 20 or 30 entries, then you can choose I8 or U8 because that's all the memory you would ever need to store 20 or 30 entries. And if we look at down here, for example, at I64, this number, I don't even know how to say it, but it's huge. And if you only had to store 20 things, you don't want to use up this much memory just to store the 20 things because you have a capacity for this many things. So it's important to choose the correct integer type based on the numbers that you're going to be working with. And I'm not going to detail each one. You can just pause the video and look at each one or if you want. And it's also in the documentation. One special case is the I size and U size. So these sizes actually change based on where the program gets compiled. So if we're compiling it on a 32-bit system, then this I size and U size, they're going to be these ones right here, I32 and U32. If we're compiling it on a more modern system that has 64 bits, then it's going to be an I64 or U64. And let's say you're working on microcontroller code, like let's say you have a drone flight controller and you only have a little bit of memory, maybe those will be an I8 or an I16. So these are going to change based on where the program is actually compiled. All right, let's recap. So we can represent any type of data with binary. And we don't, as programmers, we don't necessarily need to understand what the binary code is. We just need to be able to represent it using human terms such as words and numbers, and Rust is going to convert it for us. The basic data types are Booleans, which are true and false, integers, whole numbers, double and float, which are decimal numbers, characters, which is a single character, and string, which is a string of characters put together. And when we're working with numbers, we want to choose a number size that's appropriate for the data set that we're using.
And that's a wrap on data types in Rust. A huge thank you to Jayson for this insightful tutorial. If you enjoyed this short snippet, imagine what you can learn in the full Rust Programming Bootcamp course, which again you can find in the top right hand corner and in the description down below. Also, don't forget to like, subscribe, and hit that notification bell so you never miss out on any other future tutorials from Jayson and other expert Zero to Mastery instructors. Keep coding, keep learning, and I'll see you in the next one.